Is it better if I stand here?
I don't know.
Okay.
Wait, yeah, it's okay.
So today we're going to be learning about dilations. We've already done translations, reflections, and rotations, which are all transformations that keep the congruent shapes congruent. So the shape and its image will be congruent. And now we're going to be looking at dilations, which we learn here because it's coordinate geometry, which means it has to do with shapes on a coordinate plane. But now we're going to be making the image larger or smaller than the original. So when we look at this, the original is ABC. We know that because of the prime notation and the no prime notation. And we're taking this shape, and it's always going to give us a scale factor, or what we call a K. And in this case, it tells us that the K factor is 2, somewhere over there, where I'm telling you the K factor is 2. So you're going to multiply each coordinate by 2. So the point A, which is -2, -2, when you multiply each of these by 2, becomes -4, -4. So A prime you're going to put at -4, -4. And B, which is 1, -1, when you multiply both by 2, becomes 2, -2. And then C is 0, 2, y-axis, so 0 comes first. 0, 2, when you multiply by 2, well, it still says 0, because 0 times 2 is 0. But now it's 0, 4, because 2 times 2 is 4. So that's making it bigger. And I'm telling you, even though it doesn't say, that the K factor for this one is 2. So I'm making it twice as big as the original shape. We can make dilations larger, but we can also make them smaller. So in this case, we know that the dilation is smaller because the prime notation, the image, is smaller than the original, the non-prime notated 5-sided, 1, 2, 3, 4, 6-sided, 5-sided figure. In this case, it tells you that the scale factor is 1/3, which means you're taking 1/3 of every coordinate on the green shape. So in this case, A is 0, 0. Well, 1/3 of 0 is still 0. So A prime and A actually overlap. And then here B is 3, 3. So 1/3 of each is 1, 1. So B, which was 3, 3, now becomes B prime, which is 1, 1. So yeah, all of these are nice and beautifully divisible by 3 or easily multiplied by 1/3. If you happen to have a 5, which I'm not going to give you, but if you did, then you would still divide it by 3, and it would be 5 divided by 3, which is 1 2/3, which is going to be hard to plot, which is why I wouldn't give it to you. I'm going to give you nice, pretty divisible coordinates. So you can make it larger, scale factor that's a number greater than 1. You can make it smaller, which is a scale factor between 0 and 1. So right now you're going to pause your video. Don't stop pausing it. Great. We're going to pause your video, and you're going to do these 4. And then when you unpause your video, you're going to see me actually showing you how to do them, or the answers to them. So you're pausing, and I'm going to keep talking. You're not pausing. Don't pause.
I didn't.
Okay. So if for M prime, I take 1/4 of 8, which is 2, and I take 1/4 of 4, which is 1, so there's M prime. 8 prime has a scale factor of 2, which means I multiply 2 by 2 and get 4, and 0 by 2 and get 0. T prime means I take -2 and multiply it by -3 and get 6, and I take -3 and multiply it by -3 and get 9. And H prime, which is 12, 6, it's by 1/3, so 1/3 of 12 is 4, and 1/3 of 6 is 2. So you should have these answers, and if you don't understand it, on your little sheet you say, Miss Almeida, I wasn't sure how you got question number blank. You can pause it now, Bray.
Yay!